Blue Origin's next-generation heavy-lift launch vehicle New Glenn is supposed to be the future of the company and responsible for a host of important projects and missions. Recently, we learned from the company along with NASA that the maiden flight could be as early as next year. However, with very little progress available to the public, many doubt whether or not this timeline is possible. Fortunately, just days ago, we got a sneak peek inside the factory and learned more about where New Glenn is production-wise and what the future looks like. Instead of a barren production floor, we saw an area filled to the brim with test hardware, domes, tank segments, etc. A promising sign that progress is being made and that a lot of testing is on the horizon. Usually, Blue Origin doesn't share a lot of information on New Glenn and its development, keeping us wondering how far along the project is. As time goes on and they get closer to a maiden flight, we will likely get more updates. Here I'll go more in depth into New Glenn's production progress, the maiden flight plan, the aggressive launch timeline, and more. One of the last times we saw inside Blue Origin's factory was quite a long time ago when they were working on the New Glenn first stage mock-up. At that point, besides the structural test article, very little work could be seen on actual test tanks and components meant for either testing or flight. After this point, we didn't hear much from the company for a while until recently when new images and information surfaced. Specifically, the Senior Director for Manufacturing, Operations, and Assembly at Blue Origin during a recent visit to the facility said, "We've got a lot of product. Welding machines dot the main part of the floor. Large metal sections that will be used for propellant tanks stand near them. Tools used to make the rockets are stationed high enough so that completed stages of the vehicles can be easily moved onto trucks that will haul them to a facility near the launch pad. 4 boosters are currently in production," he said. This is a very big deal and is a promising sign for New Glenn's future. It's important to point out that Blue Origin and New Glenn have a very different approach than SpaceX, for example. With 4 boosters in production, it's possible these turn into fully operational rockets in the future, rather than quick test articles that are discarded once the necessary information is gained. Blue Origin's approach involves trying to avoid any explosions and mistakes along the way. SpaceX, on the other hand, embraces them and can iterate and learn extremely fast from constant testing. Either way, the 4 boosters being produced right now are significant for Blue Origin. While the boosters are important, no future New Glenn rocket will go anywhere without its main BE-4 engines. The topic of BE-4 engine production has been popular recently as Vulcan gets closer to its maiden flight with a busy future scheduled. This in combination with New Glenn needing 7 per booster means the engine's demands will significantly increase in a few years' time. To be specific, based on comments from ULA CEO Tory Bruno, the company can expect to require 48 engines a year, equating to 2 Vulcan launches a month. These numbers are somewhat intimidating, but Blue Origin is aware of the demand. In recent months, the company has been ramping up this next-generation engine's production by quite a bit. In October of last year, we first got a hint at this when the company said in a report that dozens of these engines are now in production to support a large and growing demand for civil, commercial, and defense launches. More recently in April, they released footage inside the regen nozzle room in the Huntsville Engines factory. Here, dozens of BE-4 engines can be seen in early production. All of this in preparation for an increase in expected demand. Even though recently there was an explosion on the test stand, they confirmed that it was a specific issue with the engine and not the BE-4 line. Tory Bruno pointed out that anomalies like these are relatively routine at the beginning of a production run. Later, however, as the automated shutdown systems get well tuned in, they become rare. He also commented that the issue is way less interesting than it sounds, just an ATP failure. They happen. That's why we acceptance test each component coming off the line before accepting delivery. We also learned a bit more about the first launch, which is expected to have a real payload aboard and not just be a test flight. In addition, it looks as if Blue Origin is aiming to land the booster for this first mission, meaning the reusability portion will also be put to the test. As far as what the payload and mission will be, we have a good idea based on launch contracts between NASA and Blue Origin. Early this year in February, the company announced that it had signed a contract with NASA and would launch the Escapade mission to Mars. Interestingly, the launch is targeted for late 2024. During this mission, it will take Escapade about 11 months to arrive at Mars after leaving Earth's orbit, where both spacecraft will spend several months adjusting their orbits before they're in position to best capture data about the magnetosphere. With this being a mission to Mars, if the launch date is missed, it will be a few years before the next opportunity due to the orbits and distance of the planet. While NASA has a good idea of Blue Origin's progress and whether or not they can be ready in time, the mission can tolerate higher risk. In a statement from NASA, they were quoted saying, "VADR provides FAA-licensed commercial launch services for payloads that can tolerate higher risk. By using a lower level of mission assurance and commercial best practices for launching rockets, these highly flexible contracts help broaden access to space with lower launch costs." In other words, they know this launch timeframe is ambitious, but it's not the end of the world if the launch date is missed. Even then, they genuinely believe New Glenn could be ready by then in around 1 year from now. Another big development relating to the first launch is the BE-4 engine's upcoming test. For the first time ever, this engine will lift off on a rocket as soon as a few months from now. While Vulcan was delayed a bit more due to a weakness in the upper stage tank dome, Torre Bruno has continued to make clear that a launch this year is not only possible, but likely. Already, the two flight engines have completed a static fire on the vehicle with promising results. Assuming the first flight goes well relative to the first stage engines, Blue Origin will receive a bunch of invaluable data on how they performed and what went well, all of which will apply to New Glenn and the eventual integration of 7 engines on the rocket's first stage. This being said, while Vulcan's main flight will be valuable, one of the engine's most important features won't be truly tested until it launches on New Glenn. BE-4 was designed from the start to be a medium-performing version of a high-performance architecture. Blue Origin highlights that it's a conscious design choice made to lower development risk while attempting to meet performance, schedule, and reusability requirements. A lot of the work that went into this engine has to do with its partial thrust, throttling, and reuse capabilities. Vulcan will expend the engines after stage separation, with the booster being discarded. The company chose LNG as the propellant because it's highly efficient, widely available, and relatively cheap. Unlike kerosene, the mixture can be used to self-pressurize its tank. Known as autogenous repressurization, this eliminates the need for costly and complex systems that draw on Earth's helium reserves. As for engine reuse, LNG also possesses clean combustion characteristics even at low throttle, simplifying this process compared to kerosene fuels. In terms of other testing, we've seen work on the upper stage of New Glenn as well. Specifically, a New Glenn upper stage test tank was spotted in the second stage tank cleaning and testing facility at Blue's Exploration Park campus. Currently, it's not clear as to what type of testing has been conducted with the test tank. It is, however, a good sign and joins the list of other components being worked on. There have even been continued fairing recovery tests, which have been going on for a while now. During these tests, they use a helicopter to drop one of the halves of a New Glenn payload fairing into the water before recovering it. New Glenn's fully reusable first stage is designed for a minimum of 25 flights. Reusing parts like the fairing could help reduce costs and improve the time between each launch as well. Blue Origin points out that the 7-meter fairing has 2 times the payload volume of any existing launch vehicle, which means more room for satellites and the freedom to build in more capacity. New Glenn is also hoping to be able to launch and land in 95% of weather conditions, making it a reliable option for payload customers. These different features could be put to the test as early as late next year. Blue Origin has been busy and currently has 4 New Glenn boosters in production at their factory. This is a good sign and supports a launch sooner rather than later. At the same time, a lot of work and especially testing is still necessary before New Glenn launches and lands its booster on a sea platform. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.